Okay, guys, so let's take a look at what we have going on. Just to kind of review, next Friday will be a quiz, or our quiz over this log so far. And then we'll have a couple of additional weeks. This week we'll be learning, kind of doing some explorations. This is the week of 319. And then the week before spring break is almost all review. It's almost all review, and then tests on Thursday and Friday. Okay, so just make sure you're kind of thinking ahead towards that. Yes. Yes, I am, for 7th period, because I had to be out this afternoon. So, yeah. All right, so
Hi, 7th period.
they are great. They are great.
Who's in your 7th period? Anybody born?
Yeah, a lot of people.
Can I say hi to Sydney?
Yes.
Hi, Sydney. It's Olivia. Your favorite.
Okay, they will enjoy that. Okay, so let's look at the homework. Okay, so we're going to start by going over the homework. And if y'all have any that you need to look at, let me know.
Number 33.
33, okay.
Did everybody else get 256?
No.
Oh, let me scroll down and y'all can see 33 better. On 33?
Yeah.
Okay. Well, let's take a look at it.
That was very
Maybe I was looking at the wrong file.
You might have been, because I don't see how you would have gotten that.
No, but like all the other problems were the same, and I just did the next problem.
Okay, well, let's do it and see what's going on. We are adding a little bit to this today, but not too much. Okay, so 33. Let me
Never mind, I know what I did.
Are you sure?
Yeah, I wrote my answer for 32 and the answer for 33, and then I just got 32 wrong.
Oh, yeah. Well, actually, 33 is something that I did not get to go over with you guys, but you probably just solved it the other way that would be logical to solve it. So let me kind of show you. It's the last part of our notes from yesterday. Basically, here we have log of, with a base of what, 25, and then 125. Okay, so how did you guys solve this? Did you rewrite it as an exponential and then change to a common base? Okay, so you probably set it equal to x, and then you rewrite it, so you get 25 to the x is equal to 125. And what would be your common base?
3. 5.
Okay, so this would be 5 squared to the x, and this would be what? 5 to the cube. So then you just focus on the exponents. So 2x is equal to 3. So x is going to be the 3/2 that we got. Okay?
Oh, yeah.
Now, it's part of the notes from yesterday. And to pull those notes out, I did get to this in 7th period because...
3 divided by 2 is log 25.
Well, it's a formula. So this is something called the change of base formula. It's an actual formula.
Why make the formula if you just like solve it?
I agree totally, but we're supposed to teach it to you. But you can do it either way. So if I have log and I have a base of m, like that, and I want to simplify that out, I can do log of m over log of b. And here's the neat thing. I can put any base I want. Any base I want. Or I can just use a calculator. So in other words, for this particular problem, it would be log of 125 divided by log of 25. Now, if you have the calculator, just plug it in the calculator. Okay? So what would that look like? That would just be log of 125. Be sure to close your parentheses and then divide by log of 25. And you're going to see it's going to be 3/2. Okay? So go ahead and pull out your calculator. Make sure you can replicate that on the calculator. And then once you get that done, I want to kind of show you the formula. Without the calculator, it's really easy as well. But I agree with Jack. Really, aren't we just changing to a common base? We are. So did y'all get that in the calculator? And to show you a neat little thing, if you get an answer, obviously y'all know that's 3/2. But what if you don't know how something simplifies. If it can be rewritten as a fraction, you can literally just do math and press enter, and it will rewrite it as a fraction for you. Cool, huh? Okay, so I'm going to go back and show you. That's my answer, 1.5. Y'all know that's 3/2, but if I want to convert something that I'm not really sure how it would convert back to a fraction, do math, and then select fraction. So I'm basically taking my answer and converting it to a fraction, and it does it for you.
Maybe give us like tutorials on these things.
I know. You will learn the calculator as we go. In statistics, you'll use, well, some of you are not taking statistics, some of you are, but AP Stats use the calculator a ton. And then when you get to pre-calc, it's kind of 50-50. It's kind of like when you need the calculator, you really, really need the calculator, and then when you don't, it's really all number crunching on your own. Yes, Olivia.
You said that we could use this and like.
If you have the calculator. So the test will be part calculator, part no calculator. So we have it spread over 2 days.
We
Yes.
had a graph that
How do
calculator.
you get like that answer turned into a fraction?
You're just going to get your answer, which was 1.5,
Yeah.
and then you do math, and you're going to basically, this is saying make it or turn it into a fraction. Press enter, and then it does it for you. So very cool. It's right there, the very first one. Now, going back to the actual problem, if I wrote this out right here, what I'm circling, and if I didn't have a calculator, could I think of a common base? 5. So if I write a little 5 in here, y'all watch, and a little 5 in there, what is log base 5 of 125? 3. What is log base 5 of 25? 2. So when they call it the change of base formula, it really is a formula, but aren't I really just changing to a common base? It accomplishes the same thing. Now, if you use the calculator, you can always use log base 10 over log base 10. So you can always do it on the calculator. But you won't always have your calculator. Okay, so that's kind of where we are. All right, so any other questions on the homework, or is that fine?
Number 64.
Number 64? Okay, so here's the answer to number 64. And
I was just confused for like what the answer is.
a log of a number is the number.
Like,
A log of a number is the number. So it's basically, this is how I wrote it out. So I have a log of the number is equal to x. Is that ever true?
I don't like. How do you test that?
Okay, well think about this. What is log of x? Well, let me put something in here. What is log of 10?
Well, your answer.
Yes, it's 1. So that simplifies down to 1. And then I'd be doing the log of 1. There's no way it could be the same output.
Wouldn't it be 1?
Well, it'd be the log of 1.
What if it was 0?
And what would that be? That would be 10 to the what power gives you 1? 0. 10 to the 0 gives you 1. So, in fact, if I replace this with a 10, the whole thing is going to simplify down to the number 0. Now, that just is what happened this time because I chose something that you could work with. But no, it's never going to be the same thing. Because it's like saying the power I need, and then I have a power like on top of that power. It's not ever going to be the same thing.
What if you put in 0? What would your answer be?
If you do a 0 here,
Yeah.
well, you cannot take the log of 0, so it would be invalid. Do log of 0 in your calculator since you have those out. It's going to say error or invalid or whatever it says. Okay, yes. 32. Okay, so for 32, I'm going to either, I'm probably now going to actually just rewrite it with a common base. After today's lesson, you have another way to solve this one. But if I rewrite to a common base, what do you think your common base is going to be? What does, and ignore the 1/2, just focus on the 2. 2 and 16 share what common base? 2. So I'm going to rewrite 1/2 as 2 to the negative 1. Does everyone agree that is still 1/2?
Yep.
And then I have my x for my exponent. And then 2 to the what gives me 16? 4. Okay. Remember that it just doubles. Like 2 squared is 4. And then, so it does like this. So when you're doing 2 cubed, it gives you 8. Then 16 would be to the 4th. Doubled 32 would be to the 5th. So you're just doubling your values there. And then you just focus on the exponent. So I have a negative x is equal to 4. Just setting these equal to each other. And then divide by the negative 1 and you get a negative 4. Just like that. Okay? Any others? Yes?
Would it be fun for those if we just like use the kind of guess and check kind of method, or do you want us to do it like finding
For ones like that, a guess and check method would be okay because you can kind of see that it's going to be something related to powers of 2, right? Yeah, you could use a guess and check. It will get to the point where you would not be able to do that. You have to follow the formula or the process. But yes, I would say that's fine for now for these simpler ones. Okay, any other questions? Okay, take out a sheet of paper for some notes. And today we're learning 2 major concepts. They're not hard, they're just kind of big, important, overriding concepts. Okay, I'm going to start with the one that we just did. Okay. Okay, so I'm going to start with number 32 just to kind of show you the other way I was just talking about. So I have log, and then I have a base of 1/2 of 16. So we just solved this one. Now, one thing that we learned yesterday that we did not get to in this class was you can use the change of base formula. So I could say, and Marissa, this is probably what she was talking about. So log of 16 divided by log of 1/2. Now, if you can't remember how it works, I always think of it as the numerator is just going straight across, log of 16. Log of 16. Y'all with me on that? Yeah, I want to do this with the change of base for you guys because you didn't see it yesterday, the change of base formula. So log of 16, and y'all, I'm using this, log with the base of m can be rewritten log of m divided by log of b. And I can put in any base I want. So I'll put it in a different color. Even this is not necessarily the same b there, guys. You get that? But I can put in any base I want. So here, what would I use as my base? So I can do it without the calculator. Very good, 2. Same thing that you did when you changed to the common base yourself. So if I do this, this is going to be, log base 2 of 16 is going to be 4. And log base 2 of 1/2 is going to be what? 2 to what power gives me 1/2? Negative 1. So do you see you get the same exact answer? Okay. The other thing I wanted to show you is if I was given a problem, like we rewrote this one as 1/2 to the x is equal to 16. The power property allows us to bring powers out front. But there's no log in this problem. There's no log there, right? Do you agree? What if I add a log here, and as long as I add a log here in front of the 16, do you think that's a legal move? Like, mathematically, can I do that? I can, because I'm doing the same thing to both sides of the equation. Now, what did that allow me to do? Well, yes, but what about the power? What do I know about this x? Where can it go? Can't it come down front?
Oh, yeah.
So I have x times the log of 1/2 is equal to the log of 16. And log of 1/2, you know what that is, but no matter whether you do or don't off the top of your head, it is just a number. It's just a number. So I'm going to divide both sides by log of 1/2. So cancel. And then look at what I have here. It is the change of base formula. So we're sort of deriving that formula. I just wanted to kind of show you that so you can understand.
How come when you're dividing logs, it doesn't just say divide?
A log of 16 is a number. A log of 1/2 is a number, and you know them to be what? 4. Well, if you put a base of 2 here, you'd have to put a base of 2 here. You know those to be 4 and a -1. Well, if I do log of 16, what? So this is what I think Caleb's getting at. Why can't you just do that? Is that what you're kind of getting at?
Would it be log 32?
That'd be log of 32, which is going to be a 5. It's a totally different answer. Okay? What's tricky is our quotient property says that if you have 2 that are being subtracted, then you can put it together with division. This is a different thing. Log of a number divided by a log of a number, you can't combine those. So very glad you're asking that question, but that is not going to give you the same answer. Because this
16 to the 1/2, that's 4, right? Like 16 to the 1/2 power.
Yes.
So is there a correlation between that and -4?
No,
Just like
not
that.
really. It's just by chance, yes. Traylon.
Is log b to b, is that always going to be equal plus or minus 1?
Log base b of b will always be 1. And remember I said this is not really the same b as this right here. I was just showing y'all you could insert whatever base you want. That was from yesterday's lesson. Log base b of b is sort of like, I call it an ancillary property. It's like an extra little property. But yes, that's always going to be a 1. Always. What about log of 1, no matter what my base? What is that going to be? 0. So these are kind of little extra properties that you don't have to know them because you understand how the whole process works. But if you know them, it just saves you a little bit of time. So log base b of b is 1. Log base b of 1 or log of 1 is always 0. It's called the log of 1 property. So kind of tuck those away as little things to help you out. Okay. We also learned yesterday that log base b and then b to some power will simplify down to what? P, right? And that kind of builds off of this one right here, this property here. We also learned that if you have an exponent, a base, and then the exponent is log with that same base, it's going to simplify down to the x there. So again, 2 extra little properties that will help you out. All right, so we're going to do some examples. A quick review of some things. So this will be example 1. Okay, so how would you do this? 2 to the x minus 1 is equal to 32. Do that one. Y'all should be able to do that one. The second one is 2 to the x minus 3 is equal to 85. And so do number 1. What'd you get? You may not be there quite yet. I'll do it. Y'all kind of work it on your own. Okay, so did you get 6?
Yeah.
Oh, I'm sorry. I'm going too fast. But y'all see it would be 6, right? So that's not a new skill. Look at number 2, though. What do you notice about number 2? We can't use a common base because there isn't a common base. We're going to have to use logs. We're going to have to take the log of both sides. So if you take the log of both sides, and it's only necessary when you don't have a common base. So I'm going to rewrite this. Log of 2 to the x minus 3 is equal to log of 85. So what I did kind of in the purple colors just show you, I'm taking the log of both sides, and it is such a powerful thing because then you can bring the x minus 3, which is a power, you can bring it down front and turn it into multiplication, which you can solve for. So I'm simply going to say x minus 3, and be sure to do parentheses here because it is a unit. It's all together. and log of 2 is just some number, and log of 85 is just some number. So how would I finish solving this? Divide both sides by log of 2, which is, these are just numbers. Log of 85 is a number, log of 2 is a number. I would get that value and then do what? Plus 3. Add 3. So basically adding 3 there. So x is going to be log of 85 divided by log of 2. We've already discussed that is not log of 85 halves. It's not. You can't do that. Plus 3. This is what we call exact form. And we'll do approximate in the calculator. This is something you either have to leave in exact form or you'd have to do in the calculator. So go to your calculator. So it's going to be log of 85. Be sure to close your parentheses, divided by log of 2, right? Okay, get that value. And then add what? 3. So my answer is an approximate 9.41. So 9.41, which is approximately 9.41. Now, you do not want to do in the calculator little by little because you lose some precision. So it's best if you kind of write everything out and then in the end plug it all in the calculator. That's the best way to approach these problems. Okay, let's do another one. So that was a skill of taking the log of both sides because you could not change to a common base. The next one's different though. Log base 3 of x plus 1 is equal to 2. Okay, how would I do this one? I can't take the log of both sides because there is already a log there. If you look back at number 2, it's an exponential equation. There are no logs. That's when you can take the log of both sides. Could I what?
Can you divide by log base 3?
You can't divide by log base 3 because remember, all of this is what? A power. It's an exponent. Could I rewrite it, though, as 3 squared is equal to x plus 1? And then x is going to simply be what? 8. Very good. So 9 minus the 1. X is 8. So I rewrote it as 3 squared is equal to x plus 1. So x is going to be 3 squared minus 1, or 8. Okay, so that's another approach to solving these. Now, do you notice at number 3, it had a log on one side but nothing on the other side? Number 2 had no logs at all. So I'm trying to help you categorize these kind of as you see the problem and know which approach to use. That's what makes logs hard. There's so many different ways you solve these. But y'all are going to be great at it, I can already tell. Okay, number 4. So number 4, I have log of x minus log of 10 is equal to 14. Okay. I have a different situation. I have logs on the left and just a number on the right. So it's not like this problem up here where I could just rewrite it. I cannot rewrite it yet. But don't I have a property that would help me condense this? Yes, very good. So it's going to be log, and I'm just going to do x over 10. This is when you can combine it. So log of x over 10 is equal to 14. Now what can I do? Can I rewrite it now? I can rewrite it now. What is my base? I understood 10. So it's 10 to the 14. So I'll kind of just take this up here. It's 10 to the 14th power, just loop it around, is equal to x over 10. So I'm going to do what to solve for that x? Very good. Multiply both sides by 10, and I will get 10 to the 15th power is equal to x. And you can leave it just like that. But it would, how many zeros would that be if you expanded it out? 15. It's exactly 15. That's one of the ways that powers of 10 work. Okay, so we have a few more to do. Do y'all have that down? Okay, so the next one, I believe is number 5. Okay, so I have log of x squared plus log of 25 is equal to 2. Again, logs on the left, no log on the right. So my goal is to get it down to what? Wouldn't it be to condense the left side?
So would it be log 25x squared?
Yes, very good. So condense the left side. So then I have log of 25x squared is equal to 2. And then I can do what?
Then you can move it around.
I can rewrite it as an exponential. So go ahead and do that. So what's my base here, though? 10. So 10 squared is equal to 25x squared. So I'm going to have 100 is equal to 25x squared. What would I do next? Divide both sides by 25. And then I would take the square root of both sides, right? Do not forget your plus minus sign. So x is going to be a plus and a minus 2. Now remember yesterday when I said you cannot take the log of a negative? Well, that's a negative right there. So you think it'll work? Okay, a lot of times it won't, but you must test or go back to the original. Go back to the original given problem. So test all solutions in the original problem. And in this case, because it's log of x squared, I can actually use the 2 and the negative 2. So both solutions do work for that one.
But if it was just x, it would not work.
If it had said something like, okay, this is tricky. If you had been given the problem like this, y'all stay with me, okay? The negative 2 would not work there. It is the same exact problem. Y'all look at the little problem, the way I changed the problem. It is the exact same problem once you bring the 2 up. But the negative 2 would not work here. Do y'all understand what I'm saying?
No.
You have to test in the original problem. So even though I bring the 2 up, and wouldn't it look exactly like this problem? See, when I brought the 2 up, it would look exactly like this one. The negative 2 would not work in this given equation. So you have to test in the original problem. Go with me? So don't do it on some, there's going to be like little interim steps you make or take. Don't test on one of those. You have to go back to the original. Okay. So just kind of wanted to point that out. And let's see. Now, you're going to really like these.
Is that sarcastic?
No, I'm serious. It's supposed to be x plus 9. Okay, now the same way that we added logs, you can actually drop the logs if they are on both sides. It's basically because of something called the equality property of logs. Which basically says if you have log of m and it's equal to log of n, what do you think is true? M equals n. So like I said, these are really easy once you get them condensed to log equal log. So do you see this looks different? Logs on both sides of the equation. So I can go right in, I can say x plus 9 is equal to 2x minus 7. And you've been solving these forever. Okay? So you would subtract x from both sides and add 7 and you would get 16. Now, you do need to test it in the original equation. But 16 plus 9 is positive and 2 times 16 minus 7 is also positive. So this would be your solution to that one. Yes?
So like you can get rid of the logs as long as they both have the same base?
As long as they have the same base. Very
So if it was
good.
like log 5 and log 4, you could.
Exactly. You also can't combine them, like condense them using our properties. They have to have the same base. Okay? Do y'all have that one or need to slow down? Okay, we really only have one more. Y'all ready? Was somebody still on that one? Okay, you got it? All right, so what number are we up to? 7? Okay, so this is going to be log of x minus 1 squared is equal to log of negative 5x minus 1. Now, you will notice on tonight's homework, you're going to have to do some condensing to get it down to a log equal to a log. And I'm going to do a recap at the end of this as to what you're looking for. So what can I do right now? I can say, I can use my equality property and say that this is what I have. So now I'm going to use algebra to solve for this. What would I do on the left-hand side? I have to, expand it out. So x squared minus 2x plus 1. Now, can y'all do that as quickly as I just did it? Okay. Y'all should be able to do that pretty quickly. All I'm doing is this. I'll take it to the side. Square this one, x squared. Multiply the 2, that's negative 1x, and double it. That's where I got that. And then square the negative 1. And the third term always has to be positive. So that's how you're going to do, like basically expanding those out quickly. Like x plus 3 all squared, you should be able to do so fast. X squared plus 6x plus 9, like that. So just kind of think about that. So that's our left-hand side, and our right-hand side is negative 5x minus 1. And when you're solving a quadratic, you have to do what? Move everything to one side. So I'm going to add the 5x, add the 1. So I'm going to end up with x squared, and then I'm going to have 3x, and then I'm going to have plus 2 equals 0. Does this factor? So I'm looking for factors of 2 that add to 3. What are they?
X plus 2, x plus 1.
Very good. So I'd get a negative 1 and a negative 2. Those would be my solutions. Well, do we actually even have any solutions? Because they're both negative. Well, we got to go back and test, don't we? We don't know right off the top of our heads. So when I plug a negative 1 here, I get a negative 2. But negative 2 squared is positive 4. We're okay. Same with the negative 3. I mean, negative 2 minus 1 is negative 3 squared. You're getting a 9. Positive. And over here, because this is a negative, when I multiply, I get 5 minus 1. It's a positive number. When I multiply by negative 2, I get 10 minus 1, 9, a positive number. So both of these solutions work. Okay? So it's not that your solution is negative and then you ignore it or don't include it. You have to test in the given problem.
If you plug it into your calculator, does that work? Because when I tried to do the log x minus, or negative 1 minus 1 squared, it said it's a non-real answer.
Okay, but it wouldn't be, it would be log of a negative 2 squared. You do it like that?
I just did negative 1 minus 1.
Because isn't this really just log of 4, which is workable? I mean, you can, yeah. When you did this? Okay, but you do log of 4, because you know that's what it really is. It's really log of 4. Yeah, you kind of, that's, so that works. Log of 4 definitely works. So it's back to the whole negative thing, but go to the original problem and plug it in. Okay, so let's recap what we have done today, just so you can make sure you understand. We're solving exponential equations. And I'm not going to solve these. I'm just going to write them out so you see what they look like. 2 to the x is equal to 10. How'd you do it? Take logs of both sides. Use logs on both sides. And then what do? You bring your power down. So bring power down. So I'm just recapping. I'm not going to actually do the problem. So that's the first thing we learned to do today. The second thing is, if you have a log like this, we learned to rewrite it and then solve it from there. Okay, so that's just rewriting. So that's when you have a log on one side. So log on one side, but a number on the other side. You just rewrite. Is everybody clear with that? Okay, and then the third thing is you want to be able to condense down to get log of m equal log of n. And as long as the bases are the same, then you know what? M equals n, and you saw from there. Okay? So that's really the three things we did today. Yes.
So like exponential equations like x equals.
Yes.
We need to show out like every time that we use log if we do it eventually.
So if you went straight from this and just did, if you thought through, okay, log of 2 would be here, bring the x down. So it's going to be x is equal to log of 10 divided by log of 2. I would at least show that last thing that you're putting into the calculator. For the sake on the test, I remember this test, we've done it several years, and students who try to do too much in their head or not on the calculator, if they make a mistake, I have no way to give them credit along the way. So do try to show your work on these. It's not that I need it if you get it right, I need it if you get it wrong. I need to be able to give you partial credit. Okay, so there is your basically lesson for today, and I want to show you, this is your homework.
Wait, so the seventh period is watch what we do, they don't actually learn? They just watch videos?
Only when I'm out. I'm out this afternoon. Okay, so this is where we are. No, that's not where we are. This is where we are today, right? So it's going to be page 296 and 297. Those are the pages in the textbook. You can grab a textbook, make a picture of it. And I would say this, there's also video, notes, homework help if you're having trouble. We still have Miss Willoughby's YouTube out here. So lots and lots of opportunities if you're having trouble.
Do you still teach this class?